So this video is going to be on trigonometry and how to solve problems involving angles in right angle triangles. Okay, so before we actually start looking at some examples, a couple of important things that we need to run through. First off, we need to know how to label our right angle triangles. So we've already dealt with this side called the hypotenuse, okay, which is the longest side. And another way of spotting that is that it's opposite this right angle here. It's the only side that doesn't have any point connected to that right angle. Okay, the next side is what we call the opposite. Okay, now this side is opposite our angle here. Okay, it doesn't touch this angle that will be drawn in the questions. And then finally, we've got this side called the adjacent. Okay, and the adjacent is the side that is touching both the right angle and it's also touching the angle in the question. All right, other than that, the other thing that we need to know, need to learn, is this phrase, SOHCAHTOA. Okay, there's many different ways of remembering it. Either remember it as just plain SOHCAHTOA, or there are many mnemonics that you can find from the internet. Even better yet, you could try and invent your own one. Okay, so another important thing before we start answering some trigonometry questions is that this is all calculator paper stuff. So you will need yourself a scientific calculator. And most importantly, you'll need a calculator with these three buttons on: sine, cosine, and tangent. Okay, if you've got this Casio calculator, which we recommend, they should be sitting just there. Okay, so let's look at some examples. Okay, so when it comes to solving questions using trigonometry, there are a number of steps that we need to take. Now, the first step is to label every side on our triangle. Now, as you can see from my example triangle here, okay, I've got a hypotenuse, which is opposite that right angle. I've got the opposite, labeled O, which is opposite my angle. And I've got the adjacent side, which is the one that touches my angle and my 90-degree right angle. So step one, label your triangle. Step two, write down that phrase we need to remember, SOHCAHTOA. Okay, notice that the way I've written it as well is in this sort of triangle form. Okay, I'll talk about why we've done that like that in a moment. What we need to answer a trigonometry question is an angle and one side. And as you can see, I've been given my adjacent. I want to calculate my opposite. And I've got this hypotenuse here, but I don't actually need it for my question. So what I'm going to do is I'm going to go through my SOHCAHTOA phrase, and I'm just going to cross out each part that has an H in it. So SO has an H in it. I'm going to cross that out. Ka has an H in it. I'm going to cross that out. And I'm left with TOA. Now then, the reason I've written this out in the way I have in these sort of triangle forms is I'm going to use this just like a formula triangle. Now, you would have been used to using formula triangles in science involving speed, distance, and time, but these ones are trigonometric triangles. Okay, so this is my trigonometric triangle here. Now, what I'm going to do is use it just like I did in science, and I'm going to cover up the side that I want to work out. Now here, I want to work out this x, the opposite. So that means I need to cover up the opposite on my triangle. Now, covering that up with a hand, I can see I'm left with a little formula here. Now my formula is tan of my angle, which is 30, multiplied by A, my adjacent, and my adjacent is 8. So if I do that, I will work out what the value of x is, what the value of my opposite is. So need a calculator for that. And my answer is 4.62 centimeters to 2 decimal places. So again, very similar to Pythagoras, most of my questions I'm going to need to round. Okay, I've got another example down the bottom here, just to run through it again. So my first step, I need to label my triangle. So I've got my hypotenuse at the top here, my 5 centimeters is an opposite, and this length down the bottom is my adjacent. I'm going to write out that phrase, so, ka, toa. Okay, it's my adjacent that is not needed, as there either isn't the side that I'm trying to calculate, and it's also not the side that is giving me a value. So I'm going to get rid of all of the parts of my SOHCAHTOA that has an A in it. So that's the ka, and that's the toa. So that's left me with this so part. Now I'm trying to find the H out, so I don't need the, and that's what I'm trying to cover up. Now you can see I've got an O over my S, so that is O opposite, which is 5, over, remember these formula triangles, it's divide if it's over, sine of 50. And that will give me my hypotenuse, which is Y. So again, going to do that on my calculator, round it to two decimal places, and I get my answer 6.53 centimeters. Okay, so what I want you to do is to pause the video and have a go at these two questions. Remember, step 1, label the sides. Step 2, write down the phrase SOHCAHTOA. Step 3, okay, eliminate the formulas in SOHCAHTOA which you don't want to use. And step 4, use the formula triangles to calculate. Okay, running through the answers then. Step 1, I'm going to label my triangle. So I've got my adjacent and my hypotenuse, and this side is my opposite. Writing so, ka, toa. I'm going to look at which letter is meaningless in the question, and that is O. So eliminate everything with an O in it. Leaves me with this ka. I'm going to be using cos. So it is my adjacent that I'm interested in finding. So my adjacent equals cos of the angle, which is cos of 25, multiplied by the hypotenuse, which is 4. Again, use my calculator and round it to 2 decimal places. I get 3.63 centimeters to 2 decimal places. Okay, looking at this one down the bottom, again, first step is to label my triangle. So I have my opposite, I have my adjacent, and this one here is the hypotenuse. Writing out SOHCAHTOA, and I'm going to eliminate everything that has an H in it, because H has got nothing on, to do with my question. So eliminating H eliminates the so and the ka. I'm left with toa. So the Y is the side that I'm trying to find out is my opposite. So in order to find Y out, I need to do tan of 75 multiplied by 15.2. Okay, so working this out on the calculator and rounding to 2 decimal places, I get 56.72 centimeters to 2 dp. Okay, so another question that you could be given is not to calculate a side, but to calculate an angle. Now, this is pretty similar to the questions we've just been doing, with a slight change. Now, before we look at calculating angles, I'm just going to bring you back to this calculator. And here, it's going to be really important to know these functions at the top here that I'm trying to highlight. You won't be able to see them very carefully, but if I just center on this one, it says in gold, sine minus 1. Likewise, here and here is cos minus 1 and tan minus 1. Now, these are the inverse buttons. Now, if you remember, to get these inverse buttons up, we need to push shift. So to get the inverse buttons up, we need to push shift and then sine or cos or tan, depending on which one we want. Okay, so back to my example now. I'm going to start this question off exactly the same way I've done before. I'm going to start by labeling the sides. So I've got my adjacent at the top here, my opposite, and I've got hypotenuse down the bottom. All right, so SOHCAHTOA, and I identified that my hypotenuse is the value that I'm not worried about. So I'm going to cross off all of the functions that don't involve the hypotenuse. Leaves me with this tangent function. Okay, so in order to find my angle, I need to cover up with my hand this tangent part, the t. So that will give me a formula to find tan of my angle. So tan of my angle is going to equal the opposite divided by the adjacent, which is 5 divided by 12. And if I do 5 divided by 12, I won't actually get my answer, my angle out. But what I've got to do to get my angle out is I've got to undo the tanning. I've got to do tan minus 1, which we just talked about on our calculator. So you're going to push shift tan to get this tan minus 1. Then I'm going to do 5 divided by 12. Now you can either do that using your fraction button, or you can just write 5 divided by 12. And then using our calculator, rounding to 2 decimal places, we get theta equaling 22.62 degrees. Okay, so I'm going to run through one more example before I give you a couple of questions to have a go at. So again, this one down the bottom, I want to calculate the size of the angle theta. So I'm going to start off by labeling all of my sides. I've got my opposite, my hypotenuse, and my adjacent sitting down the bottom here. Going to write my SOHCAHTOA out again and identify that A, my adjacent, is the thing I'm not interested in here. So I'm going to cross off all of the functions that don't involve A. Okay, so in this case, I'm going to be using sine. So I'm going to start this off by writing that sine theta equals, cover up the sine, opposite, 6 divided by hypotenuse, which is 10. Now in order to find the angle out, remember I need to do the shift sign or inverse sine of 6 divided by 10. And then using my calculator and rounding to 2 decimal places, I get the answer of 36.87 degrees. Okay, so pause the video and have a go at these two questions. Okay, so hopefully you've had a go at those. Right, let's run through the answers. Okay, let's start off by labeling our triangles. So first off, we've got the adjacent side, the hypotenuse, and the opposite. Sketching down SOHCAHTOA, I can see that it's the opposite side that I'm not interested in, which leaves me with cos. So now I'm going to start off by writing that cos of theta, covering up that cos, is the adjacent over the hypotenuse, 8 divided by 11. So theta therefore is the inverse of cos, lots of 8 over 11. Using the calculator and rounding to 2 decimal places, I get the answer of 43.34 degrees. The one down the bottom again, start off by labeling our triangle. I've got my opposite side, my hypotenuse, and the bottom one is the adjacent. Writing SOHCAHTOA. Identify that the hypotenuse is the one I'm not interested in. Get rid of all of the functions involving the hypotenuse. I'm left with tan. Start this off. Tan of theta equals the opposite, 5.4 divided by the adjacent, 6.6. So to find theta or my angle out, I need to do the inverse tan or shift tan of 5.4 divided by 6.6. Remember that you can either use your fraction button or you can use just plain old divide in order to work that out. So again, I'm just going to do that on my calculator and round it to 2 decimal places, and I get 39.29 degrees. Okay, so finally I've got another problem on the board here for you to have a go at. So pause the video and see if you can work out the value of x. Now before you do this though, just going to give you a little hint. Not only do you have to use trigonometry, but another maths topic that involves right angle triangles. Okay, so good luck. Okay, so the trick to this question is to find first the value of this side over here. So we're going to use trigonometry to do that based on this one right angle triangle. So we're going to start off exactly the same way we have been before, labeling our sides. So we've got our hypotenuse, our opposite side, our adjacent, writing down SOHCAHTOA. We're not interested in our adjacent, so we're going to cross off everything that involves the adjacent. We're left with sine. So we want to try and find this, our opposite side. So our opposite side, or y, equals sine of 25 multiplied by our hypotenuse 8. Now at this point, because it's not our final answer, I would write down my full calculator display here. The reason for this is that you tend to drop marks if your answer at the end is not fully accurate. So here I'm just going to write out my full calculator display, which is 3.38094609. Now I'm also going to keep this answer in my calculator, okay, so I don't have to keep writing this out all the time. So now that I've found y, I'm now going to concentrate on this triangle over here, and this is where I need to use another form of mathematics involving right angled triangles, but this time without an angle means I need to use Pythagoras. Okay, so Pythagoras, if you remember, my shorter side equaled my longer side squared, take away my other side squared, which was my 3.38 number squared. Now, seeing as I've already kept this big long 3.38 decimal number in my calculator, I can actually write on my calculator 25 squared minus this button answer squared, which will just do my previous answer squared, which means I don't have to write that big long thing out again. So doing that on my calculator, I end up with an answer of 613 point something 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 something. Now finally, to get my answer, if you remember the last stage of Pythagoras, I had to square root my answer. So again, using the answer button, I'm just going to do the square root of answer. I get my final answer, and this time I can round it to 2 decimal places, 24.77 centimeters. Okay, so well done if you got the final answer on that one, and I suggest that you try as many different exam type questions on trigonometry as possible. The more you practice on this, the better you will get. Okay, so good luck.